Today we're going to look at what happens when we have two ratios that are equal to each other. And so when that happens, that is something that we call a proportion. So we looked at ratios and we talked about unit rates and ratios being a comparison of two numbers. And so what we're going to do is we're going to look at two ratios and we're going to decide whether those two ratios form a proportion. And when we say form a proportion, that just means that the two ratios are equal to each other or proportional. And so we're going to talk about two different strategies for deciding whether or not ratios are equal or proportional to each other. So we're going to look at the two ratios that we have here. We're going to be looking at 10/18 and we're going to be looking at 45/81. And we want to know, are these proportional? Are they equal to each other? And so there's two ways to do this. Our first strategy that we can use is we can actually reduce the ratio into its simplest form. That would be strategy one. Strategy number two would be to use something called cross products. And cross products is something that we're going to use a lot as we're talking about proportions. So both strategies are good, and I kind of go back and forth between whether I'm going to do reducing or cross products depending upon the numbers. So looking at these two ratios, I can see that they're pretty big. The numbers are pretty big. So I'm going to start off by using the reducing strategy. So the reducing strategy is I'm going to look at my first ratio and I'm going to decide, can that ratio be simplified? Is there a common factor between the numerator and the denominator? And hopefully we notice, oh my goodness, well 10 and 18 are both divisible by 2. 10 divided by 2 is 5, and 18 divided by 2 is 9. So I can reduce that ratio to 5/9, or 5/9. Then I'm going to do the same thing with 45 and 81, and I'm going to think, gosh, is there a common factor there? Is there something I can divide both 45 and 81 by? And these are both divisible by 9. So 45 divided by 9 is 5, and 81 divided by 9 is 9. So now I should notice, oh my goodness, I ended up with two equal ratios. So we would say, yes, they are proportional. These two ratios really are the same. That's what proportional means. The two ratios are equal or they're the same. So that would be the simplify strategy that I just used right there. Now let's take a look at the other strategy that I said we could use, which is cross products. Cross products is where we're going to look at the two ratios and we're going to cross multiply. So we have 10/18 and we have 45/81. And so what we would do is we would cross multiply 10 times 81 is 810. Then we would cross multiply 18 times 45. Now, this one, if I can't do it in my head, there's nothing wrong with over to the side having to multiply out 18 times 45. There's nothing wrong with needing to do that. That's not a problem if you don't have that all memorized in your head. And so I add these up. and I get 810. And notice the cross products are the same. So again, two different ways to say yes, they are proportional. Now we can also check ratios that are in a chart to see whether or not they're proportional. So we've got a table of values, and our ratio is comparing X to Y. So I can pull any ratio out of this chart. I could pull the first one, which would be 1/2 to 4. I could pull the second ratio, which would be 1 to 8. I could pull the third ratio, which would be 3/2 to 12. Or I could look at that fourth ratio, which would be 2 to 16. Now, some of us are like, oh my goodness, some of those with the fractions are really confusing. So I probably would want to compare the two that don't have the fractions. So I want to know, is 1/8 the same as 2/16? So I'm going to use that cross product strategy. So 8 times 2 is 16. 1 times 16 is 16. So since both cross products are the same, we would say yes, they are proportional. Now again, we could do the same thing looking at a word problem. So it says you run the first 3 laps around the gym in 1.5 minutes. That's a ratio. Ratio just compares two numbers. You run 3 laps in 1.5 minutes. There's your ratio. 3 laps, 1.5 minutes. Then I keep reading. You complete 24 laps in 12 minutes. Now, when I'm setting this up, it's really important that my minutes are both in the same location. So they're both in the denominator, and my laps are both in the numerator. So again, I want to know, are these proportional? So I'm going to check their cross products. I'm going to multiply 24 times 1.5. Now again, that's kind of yucky numbers. I don't have to do that in my head. It's okay. Off to the side to do my long multiplication. And I've got, I'm working it out. It's not a big deal to have to work it out. Nobody is going to worry about that. So I end up with 36. And then over here, 3 times 12 is 36. And since both cross products are the same, we would say yes, these are proportional. So when we're looking at proportions to ratios, yes, they are proportional if their cross products are the same, or if we can simplify them to the same ratio.